All right, welcome to the video place of Mrs. Everly. So this video that you're putting in your notebook, table of contentsing it, calling it, let's call it proportional relationships. Okay, you might have something else already. Then extend it. Extend the pages, make a new page, because we're going to keep going with some more examples because you need it. So the first example we're going to do is about a school dance. So go ahead and label example 1 school dance. Okay? All right. So this school dance problem, you do not need to write out this whole thing, but I would definitely write in the numbers that you see in this table. And I'll rewrite them so you can wait. So a school dance committee purchased identical party favors for a school dance. 5 students bought different numbers of favors at different times. Each paid the same price per favor. Each paid the same price per favor. Information on the purchases is shown in the table below. So I'm going to put this table. This one's horizontal. I'm going to make a vertical table like we're used to with X comma Y, and it does say in this horizontal table that the items purchased were X and the total cost was Y. So here we go. First person out of these 5 students that we have collected data on, they purchased 10 items. They purchased 10 items. And then it told me the total cost was $5. Okay, so there's my first piece of data. So this is items, and this is money, how much it cost. Okay, the next set of data. I have 20 items purchased for $10. Then I have 12 items purchased for $6. 16 items purchased for $8. And then I have 8 items purchased for $4. Now it says here to identify and interpret the constant of proportionality based on this situation. So if they're telling me to find the constant of proportionality, it must mean that this relationship is proportional. So let's go ahead and look at those ratios and see what constant ratio is showing up every time. So remembering that the ratio is y to x, we compare y to x. So the first ratio that we have here is 5 to 10. Could that be reduced? Yes. Divide them both by 5, and I'm at 1 to 2. Okay, let's look at the next ratio. 10 to 20, divide them both by 10, and I'm at 1 to 2 again. Okay, this is looking good. If I go to the third ratio, 6 to 12, divide them both by 6, and I should get again 1 to 2. Next ratio, 8 to 16, divide by 8, and what do you know? I get 1/2, 1 to 2. And then the final one, so we don't leave it out, you can barely see it, 4 to 8, divide them both by 4, and yes, I get 1 to 2. So I have identified that constant ratio that shows up in my proportional relationship, which is 1/2. So I'm going to say in example 1 that my constant of proportionality is 1/2. And if I interpret that based on this situation, what the heck does this mean? So remember that this was a y value and this was an x value. What did the y represent? The cost in money, and the x represented the items purchased. So what could I say here? I could say the constant proportionality represents every 2 items bought was how much? $1. $1. Or I have for every dollar that a student spends, they are going to get 2 items in return. Okay, so you go ahead and write that out. For every dollar that a student spends, how many favors are they going to get? They're going to get 2. All right? All right, moving on. I have one more problem here, and this one you can label as example 2, label it mapping. Okay, some of you have seen this before because you're good at watching the videos. So in example 2, I have a part A and I have a part B. Okay, so go ahead and redraw out this map, and I guess we can redraw it in a little bit different of a way. This is just an XY table. It just looks a little different. So I have an X value of 1 and a Y value of 5, X value of 3, Y value of 7, X value of 7, Y value of 11. I'm going to stop there and see if I can figure out what the constant of proportionality is. There is something that says no constant of proportionality. That means that it's not even proportional. So let's see if our ratios are turning out to be the same. So here, my y to x is 5 to 1. Here, my y to x is 7 to 3. All right, these are already not the same. So I'm going to go ahead and circle no constant of proportionality because these ratios were not constant. They weren't the same. So this relationship isn't even proportional. So let's go ahead and take a look at part B. So in part B, if I redraw vertically this map without the circles and arrows, I have -3 going with 3, -1 going with 1, 1 going with -1, and so forth. Now let me just check and see if all these are turning out to be the same. If they aren't, I don't have to keep going. So let's check here. Y to x. I have 3 to -3. Well, what is 3 divided by -3? Well, they're different signs, so it's going to be negative. And 3 divided by 3 is 1. So I end up getting this ratio to be -1. Okay, let's look at the next ratio. 1 over -1. Again, I have 1 divided by -1. Different signs, going to be negative, and 1 divided by 1 is 1. Okay, these are looking the same. I need to make sure with all of them. So in the third set, I have -1 over 1. And what is -1 divided by 1? It's -1. It's looking good. Now the 2 that I didn't put in my table were here, so let's go ahead and try it. -3 compared with 3. If I divide those numbers out, what do you get? -1. Okay, and we need to check one more, and that's -5 to 5. And -5 divided by 5 is -1. So we have a constant ratio showing up of -1, meaning that this is a proportional relationship, and there is a constant of proportionality. So there's no way I'm going to circle that. And what was that constant ratio? -1. All right, thank you for watching. Thank you for practicing yet again. And later.